In this session, we're going to go over the process capability control chart. Now there's another one that is very similar to it, so we'll include it in here as well, and that's called process performance chart. And they're both very, very similar. So first thing we see is the histogram bars here and a histogram chart. And then laid on top of that we see our bell curve, which reflects the distribution of our sample data that's shown in the histogram chart. We also see here a green line right here. That's our target. And we can see our bell curve is a little bit to the left of our target, the peak of our bell curve. We'll talk about that more in a minute. We also see our upper control limit here, our lower control limit, lower spec limit, and upper spec limit. So the way the process capability chart works is we start out and we look at the difference between these two here. And that is called our process spread. So that's the amount that our actual process is varying. So if we took samples of a hole diameter, how much is that varying over time here, and how's our distribution of data? So that's how our actual process is doing. Then we also have specification spread. And the process capability chart is really comparing these two. So we're looking at our spec limits here and seeing how our process spread fits within our spec limit spread. So hopefully our process, like is shown here, our process is within our spec limits. And we have a little bit of wiggle room. The machine can vary a little bit, and we're not going to produce bad product. So how that fits in within here and how much we're inside the spec limits is represented by what's called the CP number. If this number is 1 or greater, that's a good thing. That means we have some margin over here. That number will be 1 if this control limit is right on the spec limit. So if these two lines were right on top of each other, this would be 1 on both sides. But that really doesn't take into account, how are we balanced out? Are we shifted to the right here? Are we shifted to the left? And this number will reflect that. It will take into account some other things here, like this difference here. This peak point right here is the mean. So that's 9999.33. The target is 10,000. So we have roughly 0.67 difference between there. And where this is derived from, we'll take a look at these numbers here, CPU. This is CPU over here. What's our distance over here? And CPL is on this side. And what we'll see is that if that CPU number is 1.0, then our spec limit and control limit will be equal. Upper spec limit. If it is greater than 1, like we see right now, CPU is greater than 1. That means we have some distance here. And the more the distance, the greater the number. If it's less than 1, That means we're to the left, and it works all the way down to 0 if we get to our target here. So we want to see a number that is 1 or greater. This is our ideal situation in a processing plant. The same applies with the CPL and the distance here. The CPK is actually whichever's lower, the CPL or the CPU. Whichever one's lower, that's what the CPK is going to be. So if you had one side here that was dangerously low, that CPK is going to represent that, and it's going to let you know you've shifted to the left and you're a little bit tight on your tolerances on the lower end. CPM represents how you're balanced out. Just in general, how close are you to target? You might be fine on both sides, but you're shifted, and you can start watching that over time too. Now we talked about standard deviation before, and basically if we take our mean and extend it down here, and then we break this up into 3 sections to the right, and we have 3 sections to the left. So from our mean to our upper control limit here, we have 3 sections. Each one of those sections is going to be 1 standard deviation. Or sigma, or it's represented by that character there. So from the mean, the upper control limit is going to be 3 standard deviations to the right, and also the lower control limit 3 standard deviations to the left. And then we're taking a look at that compared to our spec limits on our process capability here. So the upper control limit's this number, lower control limit is this number. The process performance is very, very similar, just these values have a little different formula for how they're calculated. The standard deviation's even calculated a little differently, but pretty much everything else is the same. So we can definitely see how the process capability chart can show us how we're doing, and we can look at this over time and seeing if we're starting to drift off target or our process is less consistent and we're starting to see our control limits get closer to our spec limits, and these numbers will indicate that as well. But the other way it can be used is it can be a predictor. So if you have a customer come to you and say, hey, we have this new product we want you to produce, but our upper spec limit is now 10,006.5, then you can change your spec limits on here, and it will tell you how well you can stay within that that new spec limit. And you can give them these numbers, and they know, oh yeah, they're capable of producing that that new product that we have coming out. So it can be used to see if your process is capable of producing a product with given spec limits, as well as looking in the past to see how you have been doing.